Hello everyone. So today we will discuss about cumulant generating function CGF of exponential distribution with the parameter alpha. And we need a moment generating function for that. We already done one video on moment generating function, and it is 1 minus t by alpha to the power minus 1. And this formula we will use, this expansion of log of 1 minus x we will use to expand cumulant generating function. So let us find out, and this cumulant generating function we use to find out the central moments. And using central moments, you can check whether the data is platykurtic, leptokurtic, or kurtosis, coefficient of kurtosis and coefficient of skewness we can find out, right? So let us start the cumulant generating function. Kx of t is given by log of ngf of x at right. So it is equal to, here it will be log of 1 minus t by alpha to the power minus 1, and which is nothing but minus log of 1 minus t by alpha. And now you can expand using this log of 1 minus x. So it will be equal to minus in the bracket minus t by alpha minus t square upon 2 alpha square minus t cube upon 3 alpha cube minus t to the power 4 upon 4 alpha to the power 4, and so on. It will be infinite series, right? So now using this we can find out cumulants. So it will be equal to kx of t is equal to t by alpha plus 1 by alpha square into t square by 2 plus 1 by alpha cube into t cube, or here I will write 3, and then plus 1 by 4 alpha to the power 4 into t to the power 4, and so on, right? And cumulants you will get by kr of t is nothing but coefficient of t to the power r upon r factorial, right? So we'll find out now first cumulant. K1 is equal to coefficient of t to the power 1 upon 1 factorial, and that will be equal to 1 by alpha, right? So it is equal to 1 by alpha, which is nothing but mu1 dash, and it is nothing but mean of the distribution. K2 is equal to mu2, that is second central moment or variance, and it will be nothing but coefficient of t to the power 2 upon 2 factorial, coefficient of t to the power 2 upon 2 factorial, and it will be equal to 1 by alpha square. Sorry, here it will come alpha square, right? K3 equal to mu 3, and which is equal to coefficient of t to the power 3 upon 3 factorial. So here 3 factorial is missing. So I will divide here by 3 factorial and multiply by 3 factorial. So coefficient of t to the power 3 upon 3 factorial will be 3 factorial upon 3 into alpha cube. So which is equal to 3 factorial upon 3 into alpha cube, which is equal to, after simplification you will get this 2 upon alpha cube, right? Now K4 equal to coefficient of t to the power 4 upon 4 factorial, which is equal to 4 factorial is missing here, so I will multiply by 4 factorial divide by 4 factorial. So it will be 4 factorial upon 4 alpha to the power 4, and 1 4 will get cancelled, so it will be 3 factorial, that will be 6 by alpha to the power 4, right? So first central moment is always 0, mu1 is 0, mu2 is equal to 1 by alpha square, mu3 equal to 2 by alpha cube, and mu4 we will find by using fourth cumulant. Mu4 we will find by using fourth cumulant, that is K4 plus 3K2 square. So it will come 6 by alpha to the power 4 plus 3 into 1 by alpha square whole square. So it will come 9 by alpha to the power 4. So all four central moments we have calculated. Now we will find out coefficient of kurtosis and skewness using all this, right? So coefficient of skewness is equal to gamma 1, which is equal to under root beta 1, right? And beta 1 we can get by beta 1 is equal to mu 3 square upon mu 2 cube, which is equal to mu 3 is what? Mu 3 is equal to 2 by alpha cube. So it will come 2 square upon alpha cube whole square. So it will become alpha to the power 6. And mu2 is equal to 1 by alpha square. So 1 by alpha square whole square. So whole cube, sorry. So it will become 4 upon alpha to the power 6 into alpha to the power 6. So it will be 4. Beta 1 is 4. So gamma 1 is equal to under root beta 1. So it is equal to gamma 1 is equal to 4. And the algebraic sign of gamma 1 will be the sign of mu 3. So mu 3 is positive here, so it will be 2. So gamma 1 is plus 2, therefore this implies it is positively skewed. The distribution is positively skewed. Right? Now we will find out coefficient of kurtosis. Coefficient of kurtosis is coefficient of kurtosis. And it is given by gamma 2 is equal to beta 2 minus 3. And beta 2 we can find by using mu 4 upon mu 2 square. And mu 4 we have calculated how much? It is 9 by alpha to the power 4. So mu 4 is equal to 9 by alpha to the power 4 divided by, and mu 2 is equal to 1 by alpha square, then 1 by alpha square whole square. So it will be equal to 9 by alpha to the power 4 into alpha to the power 4, which is equal to 9. So beta 2 equal to 9. And then you will get gamma 2 is equal to 9 minus 3, which is equal to 6. And 6 is positive, so therefore the distribution is leptokurtic. Implies this, it is leptokurtic. So exponential distribution is positively skewed and leptokurtic. Thank you so much for watching.